All right, so we're going to start with right above where it says key vocabulary. There is a line that we're going to fill in. So what this says is that lines and portions of lines intersect to form angles. Okay? Lines and portions of lines intersect to form angles. And so the first word we're going to talk about is what is it the side of an angle called? Angles are made up of what we call a ray, and that is just part of a line, okay, like a ray of sunshine, right? A ray is the part of a line consisting of a point on the line, so I'm going to show you in my picture over here, point A, called the end point. Okay, and it's the end point of the ray, together with all of the collinear points on one side of that end point. So if you notice, what's my end point that I highlighted in that picture? Which point? Point A. And then my ray, if you notice, it goes in one direction with an arrow on the end. Okay, so it has one starting point, one end point, and it's going to go through any other points on that line, and it's going to extend forever in that direction. And then over under that picture, it tells you that rays are named by stating the end point first, okay, and then any other point on that line. What are the two other points on that line besides A? B and C. So if you notice, they called it two different rays. They called it ray AB, or they called it ray AC. The key when you name a ray is that the end point has to be first, and then any other point it goes through. And do you also notice the symbol above it? Do you notice how it has no arrow on the left side and it has an arrow on the right? That's how you're going to name a ray. Okay, not with arrows on both, not with no arrows, but an arrow on the right side specifically. Is everybody okay with that? Two collinear, what does that mean? In the same line. So two rays in the same lines, that's what we're talking about. Two collinear rays with a common end point, or what we call opposite rays. Okay, so collinear rays. So think about this. You have your end point. One ray is going to go this way. The other ray is going to go that way. They are in the same line. They're going in opposite directions. What do they form? What does that look like? A line, okay? But when we're referring to angles, what we call it is a straight angle. Okay, or a line. Straight angle is a line. And then we're talking about this, and you're going to need to remember this. How many degrees does a straight line or a straight angle have? 180. Okay. So what that means is from here to here is 180 degrees. And we're going to have to use that quite often. So you need to make sure you remember that. All right, so looking at that picture, it tells me underneath my picture, it says BA. So BA would be here. That would be that ray. And BC, so this ray going that direction, are opposite rays. What I highlighted in yellow and what I highlighted in blue. BA and BC are opposite rays because they have the same end point and they are going in opposite directions, making that straight angle or a line. Anybody have any questions so far? Next, an angle is a pair of rays that have a common end point. Now, right under that, what I want you to put is angles are named with 3 points or just the vertex. and we'll talk about what the vertex is in just a second. And then what I would like for you to look at, and I'm going to try to point it out over there. And we'll name these again in just a minute. But does everybody see the picture of their angle here? I have point D, point A, point B, and point C listed. I could name this angle so many different ways. The vertex is the end point that they share. So it's the point that those two rays come together. What's the vertex in this one? A. Okay. So because there is only one angle in this picture, I could call it angle A. And do you see that little symbol in front of A? It looks kind of like a less than sign. That's the representation for an angle. Instead of me writing the word angle, I can just write that symbol. So that says angle A. Okay, so that's one way I can name it. But you can only name it with its vertex if there's one angle. If there are more than one angle in the same place, then we can't do that. And I'll show you a picture of that in a minute. They also called it angle D, A, B. Okay, 3 letters. The vertex always has to be in the middle. I could also call it D, A, C, because it goes through C as well, right? I can reverse those two. I could call it B, A, D. I could go backwards. Or I could call it C, A, D. And that's all of those are listed here. So we can either name it just by the vertex because there's one angle there, or we can name it using those 3 letters, or we can name it using those 3 letters. Or we can go backwards. These 3 letters and these 3 letters. The key is that vertex, that point, always has to be listed in the middle if you're naming 3 letters. That makes sense? It's important because if you go to name an angle and you name it wrong, it's going to be the wrong angle, especially when we get into pictures with multiple angles in them. Okay, the rays of my angle are called the sides, and the common end point is what we were just talking about, the vertex. So in my picture, A is the vertex, and then you have your sides AB and AD. Okay, so those 2 are the sides. The common end point is the vertex. It is very important that you can read an angle, and when I say angle BAD, that you can look at a picture and tell me where that angle is. Okay, we're referring to the angle right here. That's the angle that we're talking about. So far, so good? Anybody have any questions? Okay, an angle it's not one to write. An angle divides a plane into 3 distinct parts. And that's, yeah. So we have what we refer to the interior of the angle, the exterior of the angle, and then on the angle. The interior, exterior, and on. Those are our 3 distinct parts. So if you look at this next picture, points D, A, B, and C, what does it say? They lie what? On the angle, because they are actually points on the rays that form my angle. So that's what I mean by on the angle. Points G, F, and H are in that highlighted area there. That is what we call inside the angle, or the interior of the angle, because it's in between my 2 rays. Okay, so points G, F, and H lie on the interior of the angle. And then in the other picture, points I, J, and K, do you notice how they're below, in that below shaded region? They're not in between my 2 rays. They're below them or behind them or on the exterior of the angle. So the three distinct parts are the on the angle, the interior of the angle, or the exterior of the angle. Do you have any questions? You all good? All right, flip it over. Now, what I want to talk about are looking at your picture. Let me blow it up a little bit. Do you see all of the numbers in our picture? Okay. We also can call angles by numbers. So if I were to draw an angle, okay, and I put a number, that's not how many degrees it is unless I actually put the degree symbol. That's just another way to name an angle. I'd call that angle 1, if that makes sense. Okay. So we're going to start by answering these questions. And the first question is, name all of the angles that have D as a vertex. Okay, so remember D is the corner here. You're going to name numbered angles. You don't have to worry about naming the letters. Name the numbers. So look for point D. And we want to name all of the angles that have D as a vertex, as that common end point. Okay, we're doing part A. Naming all of the angles that have D as a vertex. D is this point right here. So we're going to name our numbered angles. And make sure when you name them that you're going to put that little angle symbol in front, okay? Angle 5, angle 10, whatever the angles are, you want to put that angle symbol in front of them. What's the first number you see? Angle 7, is that what I heard? Okay, what else? Angle 8, yep. What else? Angle 6, yep. What else? Angle 10, yep. And angle 9. Okay, so angles 7, 8, 6, 10, and 9. All of those angles have D as a vertex. You got any questions on that one? All right, then name the sides of angle 2. Remember, the sides of my angle are named as rays. You have to start with the end point and any other point on that ray. So find angle 2 and name the 2 rays that make up angle 2. Find angle 2 in your picture. You got to start with the end point. Okay, let me highlight it. Might make it a little easier. Angle 2 is this angle right here. Does everybody agree with me on that? Okay. What is the end point? Where is the angle? Where does it come together? What letter's there? Where 2 is, what letter's next to 2? B. Okay, so B is going to be my end point. So B has to come first. And let's go with this top one. How would I call that? B what? What other point is there? A. So that's going to be ray, BA. And remember to put your ray symbol above it. And then I'm going to go the other one. Okay, I can call this one a couple of different things. I could call it what one way? B what? What letter's next to B or after that on the purple part? D, okay. Or what else could I call it? I could also call it B, G, okay. Either one of those two. And with my arrow symbol above it. It's supposed to say or, sorry. So BA and BD or BA and BG. Those would be the sides of my angle. It is important that you can recognize these because we're going to be referring to them for lots of different things. So far, so good? Yes. Next, I want you to name a point on the interior of angle FDE. The interior of angle FDE. So you need to find FDE first. And then name a point that is on the interior of that angle. Everybody look at your picture. We need to figure out where FDE is, where that angle is. And then figure out what point is on the inside of that angle. If there's more than one, you only have to name one. Okay, FDE. Remember, D is the vertex. So this is what I do when I'm looking for an angle. I'm going to find F first. Then I'm going to go to D, and then I'm going to find E, and I'm highlighting it so you can see it up on my board. Does everybody see that that is angle FDE right here? Does everybody agree with me? What angle or what point is on the interior of that? A. And then the next question is talking about the same angle, but it wants you to name all of the points on the exterior. So I'm going to keep that highlighted there. And I want you to name all of the points on the exterior of that angle. There are three of them. Okay, the exterior. We named the interior. We said that was point A. What we want to know is what points are on the exterior. What points are they? C, H, and G, yes. Those are on the outside. F, B, D, and E are on the angle, but C, H, and G are on the exterior. Anybody have any questions? All right, we're going to talk about 4 different types of angles. You should know these already because you should have seen them somewhere before. But we're going to talk about and remind them again. We're going to start with acute. Oh, that's a acute angle. How many degrees is that? Less than 90, yes. So the an acute angle is anything that is between 0 and 90 degrees. We usually just say less than 90, okay, but specifically in between 0 and 90. You're going to be asked to classify angles. Oh, it's acute. That means it's small, right? If I were to draw an acute angle, I would usually just draw it something like that, okay? Something smaller than 90 degrees. What about a right angle? How many degrees is that? 90 degrees. So equals, that's not a Q, equals 90 degrees. Now, one thing I want you to remember is we can't say something is a right angle just because it looks like it. So if I draw an angle, okay, I can't tell you that that's 90 until I put a little what in the corner of that? A little box, okay? That's the only way that you know that it is specifically 90 degrees. If it does not have that box, then I cannot say it's 90 even though it looks like it should be. Does that make sense? Can't go off of what it looks like. You have to go off of what you're told. What about obtuse? What would that be? Greater than 90, but more specifically, it is going to be between 90 and 180 degrees. Okay, between 90, bigger than 90, but less than 180. That is an obtuse angle. And if I draw one of those, it's just going to look something like that. Okay, bigger than 90, but less than 180. And then we already defined this one earlier. A straight angle, how many degrees is that? 180, okay. 180 degrees, and again, we just draw that as a straight line. Okay, remember we talked about all lines are straight. There's no such thing as a curvy line. It's not a line if it's not straight. Is everybody okay with those? We remember acute, obtuse, right, and straight? All right. Congruent angles, like congruent segments, are angles that have the same size and the same shape. So it says congruent angles. It says the measure. That means how many degrees it is of an angle is the measure in degrees of the space between the sides of the angle. Okay, when I'm talking about the measure of the angle, I'm talking about how many degrees does it equal. And angles that have the same measure are congruent angles. And then I can either tell you in words that the angles are congruent, or I can tell you in symbols, like I could say that angle A is congruent to angle B. Okay, I can tell you that in words. That's what I mean by that. Or I could tell you with markings. And if you look at your little picture, do you see this little red curve here and then this little red curve here? Those are your markings that are telling me in the picture that they are congruent. Remember how on a segment we would do these little marks like that? Okay. In an angle, it's going to be two curves, or a curve that they're going to show you. So that's how they tell you that it's congruent in the picture. Then the next part, a ray or segment that divides an angle into two congruent angles is what we call an angle bisector. Remember how we discussed a segment bisector last time? Okay, an angle can be bisected as well. That means it cuts the angle in two congruent angles. You can create the angle bisector of any angle without knowing the measure of the angle. We're not going to talk about how to do constructions though, but you can do that. Is everybody okay so far? All right, let's look at what that example says. In the figure, BA and BC are opposite rays. Does everybody see ray BA and ray BC? That's basically that straight line down at the bottom, yes? Then it says that BD, ray BD, this one right here, bisects angle ABE. Okay, so that red ray, BD, bisects the angle that I have highlighted, angle ABE. And then it gives me some information that I need to figure out what X is. Everybody okay with that? So far, so good? What I need you to do is let's label. We talked about this with segments. It's very, very important to label. ABD, it says if ABD, look at that. I want you to, do you notice how they put an M in front of that? MABD? That means the measure of. So if I put an M in front of the angle symbol, I'm talking about how many degrees that is. Okay? That M means the measure of angle ABD. What does it tell me it is? 4x plus 14. So I'm going to label that in my picture. ABD is that lower angle. So I'm going to label that as 4x plus 14. And then it says that the measure of angle DBE is equal to 8x minus 32. So I'm going to label in the picture angle DBE, that is this other angle here in the middle, is 8x minus 32. And it wants me to first solve for x and then plug that in to find the measure of angle DBE. So let me ask you a question. What did it say that ray BD did? It bisects, which means it cuts it in two pieces. So that 4x plus 14 and that 8x minus 32, how would I set up an equation to be able to solve for x? I would set those equal to each other because that ray BD, the red ray, bisects the blue angle, means it cuts it into two congruent pieces. So in order to solve, I'm going to take 4x plus 14 and I'm going to set it equal to 8x minus 32. And I want to give you a minute to solve that equation. We are setting these equal because they told me that ray BD bisected angle ABE, so the red ray in my picture bisects the blue angle. So I'm going to set its two pieces equal to each other and solve for x. Remember, when we're solving, x is not going to be my final answer because they didn't just ask me to find x. I'm going to come up over here. What is that? 46 equals 4x? Is that what y'all got? And I'll do it for you since it doesn't go in evenly. If I divide both sides by 4, x is going to equal 11.5. But what did it ask me to find? DBE, and it told me DBE was 8 times x minus 32, right? So what do I do there then? Just substitute, plug it in. I'm going to go 8 times 11.5 minus 32, and I'm just going to do all that work in my calculator. 8 times 11.5 minus 32, and that's going to give me an angle of 60 degrees. Okay, congruent angles are angles that are equal to each other. So we had to set those equal. We knew they were congruent because it told me that ray BD, the red one, bisected the blue angle. That means it cut it into two congruent pieces. So I was able to set those two equal to each other, solve for x, and then I plugged that back in. I want you to try the last example. It's very similar. Okay, read what it tells you. You cannot just start the picture. You have to read what it tells you. Think about what it means so that you can label and then set up an equation. KJ and KM are opposite rays, which we can see from the picture. KN bisects JKL. It tells you what JKN is. It tells you what NKL is. It wants you to find JKN. So you're going to have to set up an equation. You're going to have to solve it for x, and then you're going to have to plug it back in. But you have to know what to set where. Label your picture. And I see a lot of you using highlighters. Highlighters are good in geometry because you can actually highlight what you are looking at. If you don't have highlighters and you want to get them, I would recommend trying some erasable highlighters. That way you can highlight and erase. But I'm not telling you have to get some. I'm just saying if you want some assistance, or you can just keep using the highlighters you have. That is perfectly fine too. You'll notice I highlight a lot of things in these pictures because it's easier to see. Label everything it says in your picture. Decide what you're going to do to set up an equation to solve for x. And once you find out what x is, you're going to plug that back in to find out the measure of angle JKN. KN, I'm going to put that in red. That ray bisects angle JKL. So there's J, there's K, there's L. So it bisects that blue angle. That means it cuts it into two congruent parts. It tells me that JKN is 8x minus 13. It tells me that NKL is 6x plus 11. What do I know about those two? Since that ray bisected it, they are congruent or equal to each other. So I'm going to set 8x minus 13 equal to 6x plus 11. I'm going to solve. So 2x is going to equal 24. Divide by 2. And x is going to equal 12. And then again, it asked me to find JKN. JKN was 8 times x minus 13. So I'm going to go 8 times 12 minus 13. That's what, 96 minus 13. So that would give me a total of 83 degrees.